Hi guys, BuildZoid here, and this is going to be an update on this lovely HD 7970 VaporX 3GB card, which if you've been, on this channel for, well, not really a while, because this channel is kind of old, so at this point, if you're not a super recent subscriber, you should be aware of what this card is. So this is a HD 7970 VaporX 3GB card that I picked up off of eBay as broken. It didn't work. And I've since managed to fix it twice. And initially, so, let's just go through the full story again, because otherwise this video is not going to be very long, and we all know how much the YouTube algorithm appreciates short videos. So, anyway, I got the card off of eBay, I think for 40 quid, I'm not entirely sure, but the issue that the card originally had is that there's a voltage regulator down here, or at least there was a... Well, no, most of that regulator is still there, it's just that the inductor isn't. But anyway, so there was a voltage regulator down here that basically produces a voltage that's supposed to be like 0.95 volts, and that powers both, as far as I'm aware, it should power both the PCIe interface and the display driver. The display drive of the GPU. And the reason why I'm saying that is that at least when doing extreme overclocking, that rail both fixes black screens and cold bugs, which cold bugs are from the PCIe and the black screens are from the display drive. So that's kind of that. But anyway, so I got the card, and the issue was that that rail was, instead of 0.95 volts, it was 0.5 volts or 0.4. Like, it was off, way off. It was like half the voltage it was supposed to be. And I basically went and, did the standard checks of like, hey, is the voltage controller working? And as far as I could tell, it had power, it had everything it needed to function. So at that point, it's like, okay, so either the MOSFETs are broken or the voltage controller is broken, and that means I would have to replace the chip, right, this one over here, which I don't really have the equipment to do yet, I'm aware that hot air exists. It's just that I don't really want to go and buy like a really cheap, crappy hot air station, then realize it's cheap and crappy and buy a more expensive one, because then I've bought two instead of just one. And I've done that with motherboards and other like overclocking related stuff, where it's like I buy one thing and it's cheap and crap, and then I go and buy a more expensive one, and it's like, well, I ended up spending more money than I initially set out, when initially I wanted to save money. So anyway, I've basically been putting off buying a hot air station for like ages and ages and ages because of that. Anyway, so that doesn't work, and I don't really have a way to properly repair it. So in my infinite wisdom, I'm being sarcastic. In my infinite wisdom, I decided to just grab the correct voltage from somewhere else. Now, we can't grab it off of VCore, because VCore normally goes to like 1.2 volts or higher, and that's just going to blow our PCIe and everything to smithereens. So that's not going to work. We can't grab it off of memory power, because that runs at 1.6 or 1.5 volts or something, just way too damn high, okay? Like, that's even worse than VCore. We can't grab it off of this rail, because I think that sits at 1.8 volts, and I'm not entirely sure what it's for. I think it might be for analog display outputs, because that rail doesn't exist on a lot of later cards. And I think it's 1.8. I'm not entirely sure. I've not bothered to check. Anyway, so, we can't grab it off of that rail because it's not even close. And then there's this rail right up here for the memory controller. The memory controller rail on a HD 7970 runs on about 0.9 to 1 volt. Which is roughly what we need for the rail that doesn't work, right? So, and originally, I had a 18 gauge red bodge wire that basically connected the output of this to where the inductor originally was over there. So I removed the inductor, right, disconnecting the malfunctioning regulator, and then I just bypassed the whole thing with this, with a wire. And that worked great. The card now had display output. Previously, it wouldn't even like output an image at all. It just wouldn't do anything. But I still had one issue. No, that's not actually... I'm skipping steps here. So, got the display output, but the red bodge wire was a bit too big. The stock heatsink for the card wouldn't fit with it. So, because as you can see, like, this thing doesn't leave a lot of space in that area. So I ended up getting rid of the red bodge wire and replacing it with these two black ones. So these are two black 18 gauge wires. And there's two of them in parallel because more current capability. And yeah, it works out quite well. I think it works out nicely. It looks a lot less terrible than the red one. Functionality-wise, I don't think, like, either of them would have probably been, just one would have probably been fine. That rail really doesn't pull that much current. But now we had a new issue. The card would run everything except, well, okay, admittedly, I only run 3D Mark Firestrike on most of my cards, so when I say everything, I just mean Firestrike, okay? But it would run everything except Firestrike Graphics Test 1. I mean Graphics Test 2. And the difference between Graphics Test 1 and Graphics Test 2 is that Graphics Test 2 is a lot more memory intensive. And essentially what would be happening with the card is it wouldn't crash, okay? Well, okay, no, it would crash. To most normal people, what it was doing looked like a crash because the screen would go black. But it wasn't just any kind of normal crash. So normally when you crash, everything on the card is still running. It's just that this thing right here is very confused about what to do next, and it needs the driver to tell it, hey, you need to, you know, calm down and start over. But what was happening with this card was it would black screen and everything on the card would shut down. VCore, 0 volts. Memory, 0 volts. This, 0 volts. That, 0 volts. Everything with an enable pin would turn off. The whole thing would just, the card would basically just shut down while the rest of the system was running. And that is a normal response for basically any any decently designed computer component when you trip a protection mechanism. Right? Basically, the thing is, over current protection, there's no real current limiting, okay? You can't tell the GPU, like if the GPU core wants 100 amps, you either give it 100 amps or you shut down the voltage regulator. You don't, you know, you don't tell it, no, I'm not going to give you 100 amps. Like, this is just not going to happen. Because if you're outputting 1.2 volts and the GPU's core's effective resistance goes, you know, low enough that you suddenly need 100 amps, well, you're going to move 100 amps or the voltage is going to drop. One of the two. And anyway, getting kind of sidetracked there. So essentially, the only way to prevent overcurrent events and overvoltage, undervoltage, and any other kind of sort of malfunction is to just shut everything down. Well, it's not necessarily shut everything down, but at least shut down the regulator that is, you know, hitting that operating condition. And the thing is, when that happens, well, that regulator basically tells the rest of the card, hey, there's a problem. And the rest of the card's like, okay, we're also going to shut down. So everything basically at that point just shuts down. So when the whole card shuts down, it's like, okay, we've tripped some kind of protection. It only happens in Firestrike Graphics Test 2. Graphics Test 1 runs fine, even if I overclock the memory, even if I overclock the GPU core. GT1 passes just fine. But as soon as we hit GT2, even at stock clocks, the card insta-crashes. So, at that point, it's like, okay, so when we have a heavy memory load, the card shuts down, and, you know, the only thing that's, like, wrong with the card is that we're powering a whole extra system with the memory controller rail, which obviously would be put under the most load when running something like GT2. So this was probably tripping over current protection. And the solution to that is either we get, you know, a proper voltage, like another voltage regulator for powering that, or repair that rail and separate them, or we do what I did, which is we're going to raise the overcurrent protection, which, so, well, we're going to somehow remove the overcurrent, well, not remove, but we're going to somehow get it to stop tripping overcurrent protection. There's not that many ways to do that. So, if you have there's some voltage controllers out there. If you have a data sheet, you can straight up just adjust the current limit. They're going to have a pin. You can adjust the current limit. That's really cool. Then there's digital controllers where you'd have to like program the current limit, which would be a pain. And then there's then there's the other option where it's like, well, you know, you can set the actual current limit, or instead of changing the current limit, you can change how much current the voltage controller sees, which is what I've actually done on this card, because identifying a current limit pin on a card with no data sheet is like on a chip with no data sheet is basically impossible as far as I'm concerned. Well, it would be really difficult to do. So then, the issue basically with this card was that this chip right here, which we're going to zoom way in on, that chip right there, is a... Okay, well, I'm not sure how legible it is, but that is a OZ micro, or O2 micro as they're now known, AM113. It sucks. It really sucks. So there's no public data sheet for that chip, which is a major freaking problem for somebody like me, because it's just like, well, how are we going to do anything if we don't know the pinout? You know, at least a pinout would, well, actually a pinout would do pretty much everything for me. So at that point, I'm like, okay, so that's a problem. You know, how am I going to lift the OCP? So instead of getting a data sheet for this, I basically went with the assumption there's only that many ways to do current monitoring. Okay, like, well, okay, there's not really that many ways. There's there's an infinite number of ways to try monitor current. There's only that many ways that are actually practical in any reasonable sense. Okay, so I went with the assumption, well, there's not that many ways to do current monitoring. I think this probably uses DC resistance of the inductor itself. So essentially, that is relying on the resistance of the choke right there to monitor the current flow through it, and use that for current monitoring. So working with that assumption, I started looking for a circuit that looks like that. And now we're going to switch over to GIMP because, well, there's not much I can show you on this card here. Well, it's harder to show you. So let me just switch over. There. So what I started looking for is something that looks like that. This right here. So this is grabbed out of a International Rectifier 3567B, no, 3567A data sheet. And so I was basically looking for something that looks like this. All right? And so we have our, I'm on the wrong layer. We have our inductor right here. So that's cool, right? We already know, we know where the inductor is. That's not a problem. Very easy to identify. We have a capacitor. There's generally there's not necessarily that many capacitors around a voltage controller, which is kind of convenient. Like, capacitors kind of give away a lot of really important functionalities because like, they're admittedly also used for like bypassing the main power for the controller, but that's really easy to check. You just stab one side of the, like, you check the voltage across the capacitor, and if you see 12 volts, well, that's probably not anything useful, right? You don't need to worry about that one. If you measure across a capacitor and you see 3.3 volts, you don't need to worry about that one either, because it's probably just bypass for the chip's power supply. But there are a lot, like, there's a limit to how many of those capacitors are going to be around the chip. So usually when I'm looking for something like, say, when I was doing the when I was volt modding Vega, I basically went, well, there's supposed to be a capacitor, and then there's going to be some resistors there's going to need to be some resistors with it, and it should have this kind of resistance to the output of the VRM. And that's how I eventually found the feedback lines for Vega. But well, this thing right here, we're not looking for feedback, we're looking for something that looks like this. And so if we take a look at the back of the card here, images are from Tech Power Up as usual. And this is actually an HD 7950 image, but it uses the same PCB as the 7970 Vapor X. So, you know, if we look around our chip here, there's this capacitor, which is way too damn big. Like, it's not going to be that. That's huge. There's that. That's huge. There's that. That's huge. We're not going to worry about it either. There's this thing, which, yeah, that could be it. That could definitely be our capacitor that we're looking for, but, you know, we're going to have to check that one. There's this one down here, which is the actual answer. That cap over there is the actual current monitoring. And then we have, like, capacitors over here. And then there's, like, this one and this one up here. And so there's way too many of them. But the thing is, I went around and checked the resistances on all of these capacitors. Just, like, right across them, right? So you just stab one side and then the other side. And the only one that looked suspicious to me was this one. And I can't remember what the other ones measured, but that one right there normally has a resistance of 7, and we're going to have to zoom out. And I'm just using the mouse here because, well, so that one normally has a resistance of 7.8 kilo ohms. across it. Okay? So that one's suspicious. Now, the cool thing is we can also see, well, actually, I think I went from the front of the card as well. So that one's a bit suspicious just because of the resistance that's on it. But if we go on the back of the card, I mean front of the card, up, there's some suspicious wires going right under the inductor over here. Like, see those traces right there? Yeah, those are very suspicious. Like, why on earth would you need to run lines that close to the inductor if they weren't used for measuring inductor current? So those are very suspicious, and conveniently we can actually figure out where these go through. And like here they go through the PCB, right? We can see the vias right there. We can use the screw holes to sort of get an idea of relatively where they're located. So if we go back to the back of the card, and this time we are actually on the back of the card, if we go back of the card again, well, I think I see our vias, right? These guys over here. There's 4 of them. They're relatively close to that screw hole. They're there's that distance over there. And this is the best part. That one traces out to that resistor over there. And this one traces out over to this capacitor. Oh, okay. So probably we are looking at this thing, right? Because one end, from one side of the inductor, we go to a resistor, check. And from the other side of the inductor, we go straight to the capacitor, check. So at this point, we've probably found what we're looking for, without even knowing what it is that we're looking for. That's the best part. And at this point, I check the resistance across this resistor is, that's actually where all of the 7.8 kilo ohms comes from. That's entirely that resistor. The resistance from this side of the resistor to the output of the VRM is 0. The resistance from this side of the capacitor to the output of the VRM is 0, so basically measured to here. So both of those are 0, which is fine, because if you actually, an inductor has effectively, the resistance on an inductor is going to be like 0.000, depending on how good it is, it can be really, 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 really freaking low. Okay, so if you see, so if we see 0, basically measuring like that or like that is the same thing, right? It's going to look the same. So at that point, we're like, okay, so this is almost, there's a very good chance that this is hooked up to one side of the inductor, and this is hooked up to the other side of the inductor. So at this point, I pulled out the oscilloscope, and actually, before I realized what I was looking for exactly, I actually stabbed every single probe point around here. But eventually, I initially pulled out the oscilloscope, then I went back to the multimeter and realized that, hey, this resistor is really suspicious. But and then with the oscilloscope, I actually checked this side of the resistor over there, and what would you know? That side of the resistor has our square wave from the running of the VRM on it. So that right there. So basically, on this side of the inductor, you're always going to have you're going to have the square wave. Right? And on the other side of the inductor, you're actually going to have DC voltage. So you're going to have flat. And that's exactly what we were seeing. And actually on here, this is not actually going to have the square wave because that capacitor filters it. That's the whole point of that capacitor, is so that you don't have, because the top of that square wave over there is 12 volts. And that would not work with the inputs of the voltage. That would not work for the voltage controller. So anyway, across the capacitor, the voltage measurement is just is basically useless. You're not going to see anything. But on this side of the resistor, we have our phase running, evidently. On the other side of the resistor, we have a capacitor. There's some resistance going to the actual controller itself, and there's another resistor going to the controller itself. And at that point, I'm just like, okay, I'm just going to go for it. Okay, I'm not 100% certain, but this looks very, very close to what I'm looking for. It's almost 99, I'm like, okay, it's almost certainly exactly what I needed. And so I smack a 24 kilo ohm resistor right across the top of that, which is actually, in my opinion, a little too big. I mean, a little too small. So The fix is that, let's just draw wires out like that. The fix looks like this. Right, and that's a 24K in this case. And I'm using a 24K because that was like the first large value. Because basically, I wanted to increase the overcurrent, like I wanted to reduce the current monitoring reading by like 10%. So actually, I wanted to get like a 50 or, well, 50 would have probably been closer to 20%, but I wanted to get like a 50 ohm, 50 kilo ohm, or a 70 kilo ohm, or something like that, right? But I don't have any 50s or 70 kilo ohm resistors in SMD, or like I'd have to go find one first on some random dead piece of hardware I have. So I started looking for, because this resistor is freaking tiny. Well, this capacitor is tiny, and unfortunately for me, if you short that, like if you put a short across there, you're going to have a really bad day because this is actually hooked up like that. So trying to solder like a big, you know, through-hole resistor onto that, just no, I'm not going to be screwing with that. That's a pain. Way too difficult to do. So instead, I went and just, you know, grabbed one of the dead GPUs I have and found a 24 kilo ohm resistor on it, and I was like, well, that's probably small enough, and smacked that on there, fired up the card runs, finishes GT2, card is repaired, really, really sketchily. Like this is just like this is not a repair. This is like on par with if your car had a fuel pump failure, and you use the mechanism that pumps your like washer fluid, you know, windshield washer fluid. Like if you use that mechanism to pump your fuel because your fuel pump stopped working, that's like on par with how I fixed this, because it's like if we go to the front of the card, right? So this thing for whatever reason doesn't work, and instead of repairing that, I'm just like, okay, screw that. We're gonna yeet that inductor out of the way. Then we're just gonna grab our freaking 0.95 volt, like roughly 0.95 volts from over there. So we're just gonna run a wire like that. Then this starts complaining that I'm pulling too much current. So well, we gotta fix that now, don't we? And so instead of, you know, doing the reasonable thing, smack a resistor on top of the freaking current monitoring, and bam. Card now runs. This is super, super sketchy. But it does run, so I'm pretty happy with it. The main concern is just not letting this voltage regulator to overheat. That's like my main concern. I don't think it's actually that much of a risk because, quite frankly, this rail really shouldn't be pulled, like, it should be single digits of current, whereas this one should be like, it's not that big a difference. Like I think this one's like 10, 20 amps, and this one's probably like 1 to 5 amps. I don't think it's 1 amp because you could probably just use an LDO if it was a 1 amp rail, but you know, it's not going to be much more than 5 amps. Because like, yeah, so, you know, I'm not too concerned, but this is definitely like one of the least correct way to repair something quite possibly ever, right? It's just like, oh, the VRM is tripping over current protection because you're trying to power more stuff with it than you're supposed to be powering with it. Oh, I don't know. We're just gonna grab a resistor off of some random dead card and use that to fix it. So yeah. There, I've repaired the 7970, and hopefully you found this somewhat interesting, and it probably ruined all of your, like, what do we say, like, erased all respect for me, because this is horrifically sketchy. But yeah, card runs, so I'm happy with it. Now the only issue is that the bearing on this fan is kind of worn out, and it eventually starts clicking if it runs for long enough. No, actually, it might not even be the bearing. So I'm not sure, but yeah, it starts making a clicking noise on that fan if it runs for long enough. So that's kind of annoying, but card runs at this point. It works. You know, I did both. Like it passed both Firestrike Extreme and regular Firestrike. So to me, that's a repaired card. And like, the thing is, I'm probably not going to run the card long enough or intensive enough to run. Like, the main issue with this is, like, I wouldn't recommend doing something like that for a card you plan to run a lot, just because, well, you're probably going to overload the memory controller VRM eventually. Right? And when that happens, it's just going to blow up. And then the card's going to be dead again. So, it's very kind of a temporary repair. But, yeah, at least it runs for me, so it's a lovely, successful way to fix a 7970 Vapor X. And actually, at this point, you can't even see the capacitor that was originally on this car, like that the resistor's on top of, because obviously the resistor's on top of there. I actually did that by like I did everything without any hot air, so I'd say my fine soldering work is actually pretty damn decent these days. There. Because, like, yeah, I did that by hand. Well, if you can see it, I did that by hand, like, so. And for removing that resistor off of a different card, I actually just took a screwdriver and, like, knocked it loose. Just, like, the worst repair person ever. This is why I don't do repairs for people. Just like, BuildZoid, fix my card. No. Like, do you want a card that's barely functional? So, yeah. Anyway, I figured I'd just share that I've finally gotten this pile of like, at this point, it is a proper pile of garbage, isn't it? Because of the way that's running. But, yeah, I've got this pile of garbage to run properly. So hopefully we'll, you know, you might get to see some benchmarks with it. Hopefully it doesn't suck too much, though. I don't have high hopes because most Vapor X cards are kind of terrible as far as overclocking goes. I really don't know why I keep buying these. Well, why I'm collecting these, because how many... I have this, I have a 79... Well, no, the 7970 Vapor X's. The 290X's, I don't know, but the 7970 Vapor X cards, there's... Like, I've not heard of many of these getting high overclocks. So I have a 6 gig one, which sucks, kinda. I have this one, which I'm not sure if this one sucks because it was shutting down in GT2. It probably does, though. And then, well, I'd probably buy another one if I find another one. So I have a problem. I need to stop buying these. These are terrible. Anyway, that's it for the video. Thanks for watching. Like, share, subscribe. Leave any comments, questions, suggestions down in the comments section below. What else was there that I wanted to mention? Right, I have a Patreon and Teespring if you'd like to support, you know, everything I do on this channel, like buying old, terrible garbage off of eBay and then fixing it in even more terrible ways. Then yeah, I have a Patreon, and there's also merch on Teespring you can buy. You can find a link to both of those down in the description below. They do actually help out immensely. So yeah, that's it for... Oh, and also the patrons get access to like a patron exclusive Discord, which I forget to mention. So yeah, that's that. Thanks for watching, and goodbye.